and it'll say just do it twice.
Sorry, is x just 2 sine?
This, and that is in the question.
Okay, okay.
So the starting value, our starting approximation is 1/2, and the next approximation. Now, if you want to be a little bit clever and use 0.75, that's fine. I'll say that's great. And if you want to do more iterations, that's great. I'm setting it up like this. It makes it as easy as possible for me to correct. But if you want to do it better, that's fine as well. So the next x value is the previous x value minus the value of the function at the previous point, which actually, in this case, we actually have it, that 0.42. I'll just bang it in here again though. So 2 sine pi by 0.5 minus pi by 0.5 all over the derivative evaluated at the previous point, 2 cos pi by 0.5 by pi minus pi. And you've got the regular marks for getting the first one right.
0.6366.
Yeah. Now it may or may not say something. It says 3 significant figures. I'll probably say 4. 4 is what you need. So what you said there, 0.6?
0.6366.
And so I'm gonna not the so if it's 4 636
No, 636. 6.
and that's rounded if necessary.
Yeah, so if you want to go with 637.
Is there another 6?
No, that's right, you know. Yeah.
Oh yeah. Okay, so maybe for this question that as it's written it says 3.
Yeah.
I'll probably ask you for 4. That should go to 0.637. Now that'll actually give me a rounding error, but it's okay. Right. And then the next one, you do the previous value using this formula minus the value of the function at the previous point.
You were saying it's alright to just bang in the calculator and just write down the answers there, JP, is it?
Using the answer.
Yeah. I mean, the only gamble is like, say if you gave me that and you gave me a number and you were in degrees, you're getting nothing.
Oh yeah, yeah.
So maybe like if it was me doing this, I'd write this one.
Oh yeah, but for x2, say, if you just put down the result, the answer for x2 and x3.
X2 and x3. Well, we only need to go to x2. Sorry, what do you mean exactly?
Oh yeah, if we just went to x2. So look, I'll just write down the whole thing altogether.
You understand? I mean, if it's right,
yeah,
all marks.
Yeah.
Problem is if it's wrong. Like if say if you write down this is like you've got most of the marks here. I don't care what answers, you know.
Yeah.
You'll only go around there in the calculator.
Yeah, yeah.
So maybe it does make more sense to write it. Maybe the second one don't bother. I mean, I can't writing this now is killing me. I hate writing all this stuff as well. Decimal points. You this one as well, do you?
Yeah, x2. Oh yeah, it's 0.6051.
605 on this one. Because the one will keep.
Yeah.
Yeah. So the only thing I can really see is maybe the derivative is a bit easier, maybe. It might be no chain rule. And it might say 4 significant figures. That's about it.
But sorry, now I know we're going back to basics. Why did you say we have to use the sine rule? Because there's two. Or sorry, the
chain rule.
The chain rule.
Because basically, if it's sine of x, off you go cos of x.
Right.
If it's anything else, you need to chain it.
If
It's sine of x squared, sine of interior x plus 2, sine of 2x, sine of e to the x.
Because x is 1 anyway, so it's just like...
Yeah, so if you're really freaked, you can just always use chain rule. And the derivative sine of x will be cos of x times 1. Yeah, so when in doubt, use the chain rule basically. C. Oh yeah, shit, one more bit. Show that this is an approximate root by banging it back in and seeing does it actually work approximately.
Will the chain rule be given like it is in the tables there, or will it be the way we learn it?
Yeah, unfortunately the big government tables are crap, so you'll have to get your own kind of understanding a little bit. Yeah. So basically, but to be honest, I use the one that on the tables a bit, but really that's not what you want to do. You want to differentiate the outside, evaluate the inside, times the root of what's inside. Most people who can follow the formula can follow that formula that's on the sheet tables. I don't know why they did that one. You can't use it. You can use it to a degree, but it's a disaster. So the other thing was just see how good is this. So sink of 0.605. So bang it into this yoke. Sine of pi by 0.605 divided by pi times 0.605, and we're hoping to get some way close to a half. Well, it won't be bang on. Oh, it's pretty good. Same about decimal places. It just says roughly, so we'll go with 3 significant figures, 0.498, which is approximately a half. Okay. Now, while there might be little bits of chain rules, obviously people, like the thing is, actually the people who are kind of a bit woolly about Laplace, obviously like they can't be, they have to do these, you know? They can't be worrying about chain rules. C. So this is the one now for anyone, this is a good question. So this is for someone who's not doing the full Laplace but should still do it. This is an easy 10 marks, I think. So Laplace, what's it say? Oh, just the partial fractions. So just do the partial fractions with that. Now I know we're kind of fighting some people about the cover-up rule, and you don't have to do it, but you better be very good at the other way. I think the cover-up rule is a no-brainer to look at, to be honest. So,
sorry, what's going on there? That last part, where did you?
Check your answer by showing that sink of or is approximately a half. Does that work?
Yeah.
Yeah, so it's the
So put in 0.605 into the sink. This is what sink is. Sink, this special function using sink. It's up at the very top of, it's at the top of question B. The sink of x is equal to that.
I thought that was a misprint.
No.
Huh?
So show that what we're actually doing is doing what it's supposed to be doing. Right, so partial fractions, what's the first step in partial fractions?
Common denominator, is it?
So a little bit ahead, factorize the bottom. And so AC is 1 by 30 is 30. 1 by 30, 2 by 15, 3 by 10, 4 doesn't go, 5 by 6, do I have to do 6?
Yeah, minus
No.
5 minus
No, I already have
I'll make
6.
that, yeah.
Can I make up minus 11 with a pair of those?
minus 5 minus 6.
Minus 5 minus 6, that'll do it. So I rewrite the middle term as s squared minus 5s minus 6s plus 30. What's common to the first two there?
S.
S, so I take out the s, what am I left with?
S minus 5.
S minus 5. Now take something out of the second two that leaves s minus 5 again. 6, not quite.
Minus 6.
Minus 6. Take out the minus 6, you'll be minus 6 by s, gives you that. Minus 6 by minus 5 will be plus 30. You have the s minus 5 there twice. So you get, take out the common factor of s minus 5. S minus 5 times s minus 6.
So see at that stage we're just basically taking one value of s minus 5, the other one cancelled out for all the one.
No.
Or was it not?
No.
Alright,
We had this question earlier. We had this question earlier, right? So you take out what's common out of these.
Oh yeah. Yeah, which I understand, but look at the next line down.
Now what's common out of this? So you got this
S minus 5,
plus
yeah.
s minus 5. So you take out the common factor of s minus 5.
Yeah.
So that's taken out as common.
Right.
And then you're left with s minus 6.
Yeah.
I mean, you may as well say, so say that 2 by 3 plus 2 by 7. So 2 3s, 2 7s, same as 2 10s. Have I gotten rid of one of the 2's? Two 3s, 2 7s. I can take one of the 3s, or I don't know how to say it exactly, but I can take, that's the same. Well, that's definitely 6, and that's definitely 14, and that's definitely 2 by 10. I haven't gotten rid of one of them.
Okay, yeah.
Yeah. Okay. So what I have is this yoke, 5 minus 2s, divided by s minus 5, s minus 6. Now I'm doing partial fractions. What rules have I got here?
Rule 1.
Rule 1, rule 1. Now if I want, I can do a over s minus 5, b over s minus 6. I can't recommend, I recommend doing cover up method. So you can have something over s minus 5 plus something over s minus 6. And when is s minus 5 equal to 0?
Plus 5.
Plus 5. So I cover this up and put s equal to 5 every time I see s. So I'm going to have, say, 5 minus 2 times s, which I will put in 5, and 5 minus 6 as well. So every time I see s, I put in 5. After covering up s minus 5. When is s minus 6 equal to 0? Plus 6, so I'll cover it up and put s equals 6 into everything else. So I have 5 minus 2 times 6 and 6 minus 5. So I end up with 5 minus, that's minus 5 over minus 1, which is 5. So s minus 5. The other one is 5 minus 12. That's minus 7 over 1. So you can do plus minus 7. It doesn't really matter. You can do plus minus 7 or minus 7. Same difference. 10 marks. Handy 10 marks. So if you're kind of, I said, worry about the Laplace, if some of the harder Laplace, so the harder Laplace I think are the straight inverse Laplace transforms. Not even the first 3 steps of differential equations. Wouldn't rule that out.
Will that always be in question 1? A kind of partial fraction?
There's no great pattern. It will be similar to year 1. Will be similar to this. Yeah, no, there's no great pattern. Okay. Next thing. Now I don't think these. I definitely think so. These are just straight Laplace transforms. Left side of the table to the right side. Some of these can be a little bit harder than others. I wouldn't not do the question. Okay, I understand you're saying, oh, I'm going to concentrate on other things, but ignoring this in the exam is just stupid. By the way, it's question 1 and 2 out of the other ones.
Yeah.
If you're anyway inclined to the class, like if it's me, I actually think I leave out question 2 if I'm doing this exam. But if you're kind of the big Laplace, if you don't like, you leave out question 3. Now the Laplace from first principles is going to be in question 2. And I'm going to pretty much tell you what's coming up in that. So, let's see. Okay, so the thing we're sending here is 6 cos 6t plus t squared minus 12. Now what is the easy thing about this? Thing that makes this an easy question?
There's only cost and no sign, is it?
Not quite. If you're going to send that, you can do them individually because they're added together. If any stuff is multiplied together automatically, it's more complicated. Now this is little f of t, so I'll send it to big F of s. Now constants, fixed constants, so fix the 6, constants that multiply. What is cos 6t set to?
S over S squared plus 6 squared.
Yeah. S over S squared plus 6 squared.
You want to remove marks for the notation, JP, if we don't have the notation right, say the big F of S.
If you write this is equal to this, I'll feel like doing it. That'll piss me off.
Yeah.
To understand now, strictly speaking, I'm well within my rights. If
Yeah.
yours is the first paper I see, like this is the real world. You know, this is the real world. If it's the first paper I see, I'll be 10 more lads doing it, I'm going to get sick of it, I'm going to go back and say, do you know what, I should be punishing this. It's not showing understanding. They're not the same.
Will you correct mine first? So
No.
But JP, would that not reflect on the teacher if there's 10 plus 1?
No, I'll put it this way. Look, if no, honestly, a question like that, just so you know, often you have a whole class doing really, really well. I don't take credit for that either, honestly. Okay, so that answers your question. No, I won't feel bad about that. Right, what does t squared get sent to?
That's 2 n
What's your n?
2 factorial
factorial
over S
S.
power 2 plus 1.
Yeah. And what does minus 12 get sent to?
12 over, minus 12 over S.
Yeah, now, yeah, I think the way you said it was perfect. So I can fix the minus if I want, and then 12 over s. Now, you want to tidy that up. You could leave that, maybe turn that into 36. Don't leave that like that. There will be a mark for tidying that up. Best would be maybe 6s, s squared plus 36, plus 2 over s cubed, minus 12 over s. Now, I don't see why you wouldn't do that question, for example. Right. I definitely want to see that. You know, I probably actually made that worse. That's probably better than that, but I definitely want to see that. Yeah. The next one, 20 minus 10, 1 minus e and minus 2t. Now this, so what would actually be a good idea to do first here?
Multiply over.
That's a good idea, right? Now just in case people are doing other things, you don't actually have to multiply it out. And I'll just show you, I'll tell you why, because ultimately it's not really it's not multiplied by another function, it's multiplied by a constant. So if you want to do, send that, fix the constant, and then send that, if you really want to. Now maybe what I should probably do, you would multiply out is what you should do, but I'll just show you can do it this other way, it's okay. So this yoke is called little g of t, so this should be sent to big G of s. Now Sean, if you give me a squiggly arrow, or a squiggly arrow with an L, or an arrow, therefore it's the equals I hate.
Okay.
Just showing that you're translating it somehow. So, do you need this? No. Just to, don't write that equal to that, that's not good. So this would be a bad way, but perfectly okay. So send the 20, now the 20 is on its own. The 10 is not going to be sent in the same way because the 10 is multiplying. So this 20 is on its own. What does 20 get sent to?
20 over S.
20 over S. Now, if a constant times is different. Now, if you want some table, the big longer tables actually says that this is 20 times 1. And you fix the 20 and 1 is sent to 1 over S. But it's easiest, well, this can be troublesome for us, but this one now, you're not sending this because it isn't on its own, it's multiplied by something else.
1.
Now, if it's a constant, you can just fix it. Because it's a constant multiplying.
So it's a 1 over S and it's 1 over S.
Yes, no. 1 over S.
1 over
Fix
S,
the
yeah.
constant,
Yeah, and
send this.
what's in
Yeah, and this is a sum itself, so this can be sent separately. 1 over S,
minus your exponential goes to
and what does your exponential go to?
S plus 2.
1 over S.
Plus
1
2.
over yeah.
Now, you're much better off multiplying this out first, and would I give the marks for that? I think I would. Yeah, you could multiply